Hello, biology students. Paulus here, and the purpose of this video is to give those students who were handwriting and I went too fast, or students who missed part or all of the Zoom meetings when we were taking notes on section 4-1. Remember, rule whenever you are doing class notes, they need to be in Cornell note style. That'd be the question on the left and the answer on the right, and please number them appropriately. These notes go from number 1 through number 11. So if you're doing a Google Doc, you'll need 11 rows, 2 columns. If you're writing them by hand, you're going to draw a line down the center of your page. Remember, because this is a video, you have the ability to pause and restart the video. Therefore, I will not be spending as much time on each slide as I do in class. And one last thing before we get started. Oh, go Ducks. Pac-12 football starts tomorrow. Really excited. All right, here we go. Weather and climate. So people don't, well, yeah, I guess they do hang out on the porch and talk about climate because it's all messed up right now. But really, you think of two old farts sitting out on the porch. Hey, how about the weather today? They're not talking about like what's been happening over decades. They talk about what's going on currently. So weather is day-to-day conditions in the Earth's atmosphere. Okay. Climate, the average year after year conditions of temperature and precipitation in a particular region. So climate is kind of like the average weather that you have over long periods of time. Go Ducks, or Dusts. Remember, if you are muting me because I annoy you, or you're muting me simply because you want to listen to your own music or whatever the case may be, the way that you will know I'm getting ready to go to the next slide, and therefore your opportunity to pause the video, is I will do this. I'm getting ready to go on to the next slide, so okay, climate, trapping the heat by the atmosphere, so the greenhouse effect. Latitude, so if we're at the equator, distance north towards the North Pole is north latitude. Distance south towards the South Pole is south latitude. So it's distance north or south from the equator. Heat gets transported. The excess heat is absorbed at the equator. Heat gets transported north and south by wind and ocean currents. Amount of precipitation, you can just use rain as long as you know that fog, hail, sleet, snow, graupel are all forms of precipitation. You can just write rain. And also topography, the shape of the Earth's surface. And topography even can mean the shape of the ocean bottom, which technically is the Earth's surface. All right, moving on. Okay, so how does the greenhouse effect? You can just do GHE. Maintain the Earth's temperature range. Remember, every time you see capital T means temperature. So there are certain gases, carbon dioxide, methane, carbon monoxide, water vapor, ozone, even chlorofluorocarbons, which we don't really talk a whole lot about. They absorb solar radiation. And these gases are in the layer of the atmosphere closest to the Earth's surface. Excuse me. Therefore, they keep the heat close to the surface. Okay, so these are called greenhouse gases, or you can write GHGs if you would like. All right, so the greenhouse effect itself, it's a natural phenomenon. It's a natural process where heat is retained or kept in the Earth's atmosphere by this layer of greenhouse gases. And remember, the not that any greenhouse gases are more important than the other, but the one that we are most concerned about right now and over the coming decades is methane. Tundra and permafrost, which are regions that remain frozen, all year round are melting because the atmosphere is warming. And they're releasing the stored methane underground. Methane is 23 times more powerful in terms of its ability to absorb solar radiation. So one methane compound is equivalent to 23 carbon dioxide compounds. So if we start releasing a whole bunch of methane inadvertently, it's not like we're going and using a blowtorch to thaw out the permafrost, but areas that are normally cold during the summer are now warmer during the summer, and they're thawing and they're releasing that underground or under ice methane. And you think it's bad now. Oh, just wait until we pump a whole bunch more methane up into the atmosphere. All right, getting ready to hop ahead. Okay, please use this as an opportunity to practice with your notes. Of course, some of you guys are fast forwarding to the next set of notes, but this is a great opportunity for you guys to practice, do a little bit of studying while you're taking the notes. Remember, we don't take notes. Well, I don't make you take notes to punish you. It is a form of learning, and it gives me an opportunity to point you in the right direction and for you guys to have aha moments, etc., etc. Okay, so if you're not sure about this one, take a look back at number 1. Of course, if you think that climate goes in the first blank and weather goes in the second blank, you're going to choose this one. If you think that weather goes in the first blank and climate goes in the second one, you're going to choose this one. What do you guys think? Yeah, it's option 2. Weather is the day-to-day. Climate is the average year after year, long term. 2 things that cause climate. If you can't remember, take a look back at number 2. See if you can do them all. See how many you can remember before you actually look these up in number 2. Yeah, so I'm thinking topography, shape of the land, latitude, how far north or south of the equator you are, ocean and wind currents, greenhouse effect. I'm missing one. Amount of precipitation, amount of rainfall. Describe how the greenhouse effect keeps the Earth's surface warm. If you can't remember, take a look at number 4. Yeah, so these greenhouse gases, carbon dioxide, methane, carbon monoxide, water vapor, ozone, chlorofluorocarbons, missing one, water vapor, they are able to absorb long wave solar radiation that is radiating off the surface. And they keep that heat close to the surface, and that's where we live. So that is what keeps the surface warm, is the fact that these greenhouse gases can absorb solar radiation. Actually, it's long wave solar radiation that gets absorbed from the sunlight, and then it radiates back up into the atmosphere. Good. So how does latitude is defined as the distance north or south of the equator, affect climate? Deals with the angle that the sun's rays come in. Oh, check this out. I'm going to show this off. One of my ex-students and TAs made this for me in ceramics class. Rebecca Fasolo, 2014. Mary Duckmas, Paulus. It was a Christmas present, obviously. Pretty cool. That's how it's supposed to be set. Okay, so the angle of the sun is different. So the angle of the sun is almost 90 degrees at the equator. Matter of fact, sometimes of the year it is, and it depends on where you are near the equator. It is exactly overhead. So more of it gets absorbed. Whereas at the poles, the sun comes in at a lower angle. And remember, the poles are made out of ice. A lot of that sunlight bounces right off the ice and goes back out through the atmosphere. So less radiation is absorbed at the poles, more radiation is absorbed at the equator. That's why the poles are cold and the equator is warm. All right, 3 climate zones: polar, the cold one; tropical, the hot one; temperate, it's cold sometimes during the year, and it's warmer sometimes during the year. So the temperate really has seasons. Polar region really doesn't have seasons. Winter's cold, summer's cold, spring's cold, fall's cold. Tropics, summer's hot, winter's hot, spring's hot, fall's hot. So they don't really have seasons at the polar and tropical. So really, seasons and latitude, the distance north or south of the equator you are, affect the varying temperatures in the temperate regions. And I suspect that's why they named it that way. Moving on. All right, so here's a good diagram. So notice the sun comes in, I don't know, that's probably like a 30-degree angle, okay, a lower angle. A lot of this is going to bounce right off the Arctic or bounce right off Greenland and fly right back through the atmosphere back out into space. So less solar radiation is absorbed, meaning you're going to have cooler temperatures. Whereas here, it's coming in at 90-degree angles. And, maybe up here it's going to be closer to like, 80 degrees or 75 degrees. But still, a lot of this is going to get absorbed by the land or the ocean. And once it gets absorbed, that heat can get trapped in the atmosphere because it switches from shortwave. It comes in, visible light is shortwave radiation. Once it gets absorbed, it radiates off as infrared radiation, which is long-wave radiation, and it's easier for greenhouse gases to catch that radiation in the atmosphere, keep the heat near the surface, make it warm enough for life to exist. All right, polar zones, they're cold. This little circle up here, that means degrees, so we're not talking about temperature. We're talking about angles. Okay, so between 66.5 degrees and 90 degrees north and south. So, of course, we're talking about the North Pole and the South Pole. Boy, would Kris Kringle, Santa Claus, be upset. He probably is upset about how we're jacking up the planet. I mean, his reindeer are sweating. It's crazy, man. Okay, temperate, that's where we are. Sacramento is about 38, 39 degrees north latitude, if I'm not mistaken. So between 66.5 and 23.5 degrees north and south latitude. More affected by the seasons. Obviously, the closer to 23.5 degrees you get, the less seasons you get. The closer to 66.5 degrees you get, the less season you get. But if you're in the middle, kind of like Sacramento is, you're going to have 4 distinct seasons. Obviously, the beginning of spring resembles the end of fall. The end of spring resembles the beginning of fall. Summers are hot, winters are cold. And again, that's distance from the equator, and more importantly, the angle that the sun comes in at. Because remember, the Earth is tilted 23.5 degrees, and as we orbit around the sun, that changes the angle depending on the time of year it is. So obviously, the angle is going to be higher in the summer and the spring, and it's going to be lower in the winter and the fall. Hopping ahead. Tropical zone, or the tropics. That's between 23.5 degrees north and south latitudes, between the Tropic of Cancer, Tropic of Capricorn, and the climate is almost always warm. The only exception to this rule would be is if you have maybe a coastal area that's near an ocean that has cold water. That could make it cooler than you would expect. And a common misperception about the tropics is that that's where you're going to find all the rainforests. You do find many of the rainforests at the tropics, but there are actually deserts at the tropics. The Sahara Desert, the largest desert in the world, is at the equator. And there are a couple geographical, topographical reasons why the Sahara is dry. Primarily, the ocean current off of the west coast of Africa is a cold water ocean current, so there's going to be less evaporation. Okay, less evaporation means less clouds less rain. Also, and this is kind of the reason why Sacramento and the Sacramento Valley is wet and Nevada is dry, there's a mountain range in between the Atlantic Ocean and the Sahara Desert. So what happens is any water that has evaporated and formed clouds, as that moisture and that moist air gets pushed up and over the mountain range, it gets colder. The water vapor molecules stop vibrating as much, and they get closer and they get closer and they get closer together. It's called condensation, and they form raindrops. And those raindrops fall on the western side of the mountains, and they run right back towards the ocean. So when that air goes up and over the mountains, it's very, very dry. The clouds don't have as much moisture in them anymore, and that's why you don't get a whole lot of rainfall in the Sahara. So cold water ocean currents off the west coast of Africa, and the water vapor being pushed up over the mountain, which is called the rain shadow effect. Same thing happens. That's why we get a lot of rain on the western side of the Sierra Nevada. When that air goes up over the Sierra Nevada, past Tahoe, and down towards Carson City and Reno, there's not a whole lot of water vapor in the air, and you don't get a whole lot of rain. You get a whole lot of clouds. Okay, moving on. Okay, why do the lower latitudes near the equator absorb more sunlight than at the poles? If you can't remember, take a look back at number 5. Yeah, the lower latitudes near the equator, sun's almost directly overhead. More solar radiation gets absorbed near the equator than at the poles, because at the poles, the sunlight comes in at a lower angle and more of it bounces off and less of it is absorbed. Okay, so the poles aren't cold because they're cold. They're cold because they don't absorb as much sunlight, radiation, as the equator does. 3 main climate zones. Take a look at number 6 if you can't remember. Polar, temperate, tropical. Match them up. Oh my goodness, I hate it when this happens. Man. Stop it. Now we're good. Yeah. All right. Which one's polar? So you can take a look at 7, 8, and 9. All right, polar is obviously B, cold. Temperate could be hot or cold because they have seasons. And tropical is going to be hot. All right, here we go. Last slidocito. All right, so heat transport. So remember, the Earth, like many natural, well, all natural systems that we know about, at least on this planet, likes to balance things out. So because there's excess energy absorbed at the equator, the Earth needs mechanisms to take that excess energy and distribute it equally to the poles. So it does that in the atmosphere through wind currents, and it does it in the ocean through ocean currents. So what happens is the warm air at the equator rises and it moves towards the poles. And when it gets to the poles, it's colder there. So the air gets more dense and it sinks and it moves back towards the equator. Same thing happens in the ocean. When you get water on the bottom of the ocean near the equator, it's warmer there. That water rises and it moves towards poles. The poles, because the air is colder and the water is colder, it sinks and it moves back towards the equator. These big, massive circulation patterns that have taken tens of thousands of years to form, many of them are in jeopardy because we're jacking with the climate. And remember, areas that are wet now are going to be wetter in the future. Areas that are dry now are going to be drier because we're messing up all these circulation cycles that the Earth has developed over tens of thousands, hundreds of thousands of years. And there's not like any way that you can just flip a switch and get them to go back. So that's going to be really dangerous for our future. Surface currents, this is one of the two types of ocean currents. This is when water gets moved or blown by surface winds. And again, I mentioned this when we were doing the notes in class. Cities, regions that are near oceans or large bodies of water typically are cooler than areas that are not. On a hot day in Sacramento in the mid 90s or maybe even 100, you drive an hour and a half to San Francisco and you're going to drop probably 15 to 30 degrees in temperature. And that's simply because the molecules of liquids are further apart. Okay, so it's a lot harder for heat energy to transfer from one molecule or one atom to the next. So it takes a lot more heat energy, heat up water. Therefore, the air above oceans or really large lakes is going to be cooler than it will be over land. Solids, those molecules are packed closely together. The heat is transferred a lot more easily between the atoms or the molecules. So San Francisco and many coastal cities are referred to as maritime, maritime climates, and they're cooler in general. There are, I am sure, some coastal cities that are really, really, really hot, but I would venture to guess that the water off their coastline is going to be warmer. It's probably a surface current that's moving from the equator up towards the poles. The water off the coast of California is the opposite. It's moving from Alaska up near the pole down towards the equator. So the water is really cold off the coast of California. Getting ready to bump ahead. List 2 ways that heat is transported in the biosphere. If you can't remember, boy, we just talked about it like 45 seconds ago, but take a look at number 10. Yeah, in the air, wind currents, in the water, ocean currents. Good. Okay, the Earth's polar zones are cold. Why? Can't really tell you where to look. Yeah, you're right. B. It's because the sun comes in at a lower angle, less solar radiation gets absorbed. Good. The upward movement of warm air and the downward movement of cool air, what does this create? Movement of air over large regions in a predictable pattern are called air currents. Good. Earth's temperature range is maintained. What is that natural process that maintains the Earth's temperature? You got it. The greenhouse effect. Variation of temperature in the temperate zone. Why do we have... Almost gave the answer away. Why does the temperature vary throughout the year in the temperate zones? Yep. Distance from the equator, latitude, and seasons, which basically is the angle of the sun, varies from one time of the year to the other. Last one. The tropical zone is warm all year long because... yeah, it receives direct or nearly direct sunlight year round. All right, ladies and gentlemen, that is it for the 4-1 class notes. Remember, these need to be numbered appropriately. Question on the left, answer on the right. And ladies and gentlemen, I will see you in the Zoom.